All right. One more reminder. This was up yesterday, but Chapter 2 retakes ends tomorrow. Cutoff for retakes through Chapter 3 is a week from Tuesday, and then that day we will also have a quiz. You can retake things from that quiz through the rest of that week, but the week of finals, there's no retakes. Any questions about that? I know basketball is important, guys, but I'm sure Coach will let you out of practice for a little while if you need to do retakes, okay? Would you like me to contact Coach if you need to do a retake? Okay, before school or whatever, yeah, or before practice. All right, guys, the first question is what we did yesterday, and it says use logarithmic model. It's also possible on the quiz that it could be either exponential or logistic. Okay, those are the three we learned yesterday. What is the calculator for logarithmic? Do you remember? No. It's EXP, the ones we learned, ln, reg, and logistic. That's my concern. Did I spell that right? Anyway, logarithmic is actually this guy, right? It's the ln. All right, let's put this in, which I have not done ahead of time. So my recording is going to be longer than it needs to be. Austin, can you read me the numbers? It goes faster.
1, 3.
Okay. What's the deal? Apparently I can't type, or I type too fast. All right. Sorry.
3.
Did I get them right? All right. So if we look at the stat plot real quick, list 1 and list 2, which I of course don't have. And then a quick zoom 9. Oh, I have something in y equals. All right. So logarithmic is good because it's growing, but the growth is slowing, but not totally flattening out necessarily. So, and you don't have to draw a scatter plot tomorrow. So if you just don't even turn the scatter plot on, it's up to you. The scatter plot does help you see how well it's fitting. All right. Then it said logarithmic regression. So it's number 9. And I use list 1 and list 2. And I want to store the equation. All right, so I'm afraid that Crazy Hofbauer may have, oh shoot. Where's this silly calculator? Why can't I minimize that? All right. I think I may have said like you have to go out a lot of places on the quiz. So it says A, which would be 15.011 plus B, which would be 19.993 ln of x. How many ants will there be at week 35? Would be, if you have it on Ask Auto, you can just go in and ask it for 35, or you could scroll down. But that one you just want to round to a whole number. But the answer is not 86 ants. Does anybody see why? This is important for the quiz tomorrow. Yes, Nolan. This is in hundreds of ants, and it's stressed here again. It's hundreds of ants, so it's 8,600 ants. Everybody okay? Sorry, it took way too long on that question. Number 2 is a question you need to type in the calculator, and you need to be able to type it in correctly. Please be doing this with us, guys. You do have to turn your plot off, and again, tomorrow, if you don't even turn it on, it's fine. And then we need to type this equation in, 1450 divided by, you will need a parenthesis, 1 plus 52. Second ln to get the e. Is it negative 0.6? X? Be careful. Read those very carefully, okay? Because it's really easy to put, 0.06 when it's 0.6 and all kinds of stuff. All right. And then we need to graph this to find some of these values. So what's an appropriate window? Guys, don't do zoom fit. What's an appropriate window? Do we need negative values a time? No. So 0. Does it actually tell us how far to go out? No, it says when will there be 100 deer. So I don't know. You want to go 30, 50? I'm gonna try 30. See if that's enough. Deer can't be negative. And what's it going to max out at? Do I kind of already know that? Probably 1450, right? So I'm going to put 1500. Oh, that looks pretty good. Okay. So what is the population at times 0? What do I do there? Trace 0 is the easiest way. And it doesn't come out nice, but is it about 27 deer were initially introduced? We just did trace 0. Everybody okay? When will there be 100 deer? That's a Y value, so what are we going to do? You look at the table to get close if you turn it back to auto, but remember how we solved this exactly? This is on the quiz. We need to put in a line at y equals 100 for y sub 2, and then find where they intersect. Just leave them there. Thank you so much. What? Yeah, just put y equals 100 because we want to know when the population hit that. So the easiest way to do that exactly is to do a point of intersection and about 2.25 years. Does that seem okay, guys? Any questions on that? What is the projected maximum? Again, you could scroll out a little ways. We could trace out to 25 years, but it should be what? Yeah, that 1450 number on the top. Any question? Okay, we put in y sub 2 equals 100 and then found the intersection point. Yeah. Because we wanted to know when the blue hit the red exactly. We good? All right, number 3. Oh, it's been a while, but I did a couple warm-ups this week on these. Anybody? How do you solve this? It doesn't say factor, but that's what you got to remember is that this is a factoring question. So if we pretended this was 3u squared minus u minus 10, how would that factor? It's not nice. I hope it's nicer on the quiz, but I don't know if it is. 3u and u. If I put the 2 here and a 5 here, that would be 6u. If I make that negative, plus 5u. That's an icky one. Does it work? 3u squared plus 5u minus 6u would be negative 1u in the middle and minus 10. All right, so I'm going to go back and rewrite it with the e to the x. What does that mean this would be with the e to the x, guys? We have 3 e to the x plus 5 and e to the x minus 2. Okay, now what? If I set 3e to the x plus 5 equals 0, what happens? I get e to the x equals negative 5/3, but then I have to take the log, move the x out front. Is that working out so well? Can you take the log of a negative number? That one's all garbage anyway. All right, back to this guy. This one, if we set it equal to 0, we just get e to the x equals 2. And then ln of e, move the x out front, equals ln of 2. So ln of e is just 1. So the exact answer is the natural log of 2. You don't have to have those parentheses. And then to the nearest hundredth is just what we get when we type ln of 2, which is 0.693. Oh, that's not hundredths. Just 0.69. Questions? For more practice on that concept, do your bookwork on page 196. I think it's numbers 50 and 53 are like that. Be my guess. I'm not positive about the numbers. Okay. Number 4. Yeah. Oh, no. Don't have a question? Good. Okay. This is what somebody's going to do. Can't do that. Okay. What can we do? Okay, so we can condense, and if we condense this side, the whole reason we had to learn those silly rules, what happens when we have a log base for x minus 7? So it's x over x minus 7 equals log base 4 of 8. Now what? Yes, because we have log of blob equals log of blob, the two blobs have to be equal, so we can get rid of this. And we have x over x minus 7 equals 8. If I kind of think of it as a cross multiply, so we have 8 times x minus 7, which is 8x minus 56. Or negative 7x equals negative 56. Did anybody get x equals 8? Is that working? Anybody get positive 8? Okay. If I plug it back in, I'd have an 8, and this would be a 1. Does that work? After you did 8 minus 7, you'd get the log of 1, right? And that's okay. And it would check. Just make sure you're not putting it back in and it comes out negative. Can't take the log of a negative. Questions on that one? Number 5, same kind of question? Yes or no? No, because there's not a log on this 2 over here. We do still have to condense. What do we have to do over here? Log base 3 of x times x minus 8 equals 2. Now, how do we get rid of a single logarithm? Yeah, we can exponentiate, or my thinking is we just rewrite it. It's base 3, exponent power 2 equals whatever was on the other side. Same idea. All right, so I have an x squared minus 8x equals 9, or x squared minus 8x minus 9 equals 0, which factors x minus 9 and x plus 1. Did I factor that right, guys? So I get 9 or negative 1. Did I lose anybody? Is that working? If we put a 9, we'd have a 9, and 9 minus 8 would be 1 over here. Can you take the log base 3 of 9 and the log base 3 of 1? So that one's working. Can you do negative 1? No, you can't take the log. It just said log base 3 of negative 1. That doesn't work. Let's use our brain for a second here to check this. What 3 to what power is 9? 3 to what power is 1? So can we just check it using our head? It works, right? All right. We haven't done a lot of these, but it's on the quiz. Any ideas? You need to rewrite this. Yeah, you can call it exponentiate or rewrite this. What is the base? Because it's ln. No, because it's ln, the base is e. If it was plain old log, it would be 10, and one version of the quiz probably has that. So we can do both sides or just rewrite it. See, I would have just thought of it as e to the y equals x plus 7. But is that the same thing you're going to get here because this e and ln undo each other? Okay. Now, I'm supposed to get the x by itself. So what do I still have to do? Subtract 7. So I write x equals e to the y minus 7. Anybody need me to make up another one of those? What if it said, what would you have to do first there? Divide by 2. Sorry. Then what? And this would be a base 10, yes. So you'd have 10 to the y over 2 equals x plus 3. And then you'd have to subtract the 3. So you'd have x equals 10 to the y over 2 minus 3. So that was a little more complicated one, but wait a minute. Did I mean to write? Okay. I don't know what I meant to start this with, but I used plus the rest of the question, right? We good? All right. Then we get to the application ones. We have Newton's law of cooling. And remember, the T sub n just means the surroundings. Okay, so what is the oven temperature going to be? But what am I putting that in for? Yep, original temperature. It cools to 260. So for the first part, that's my final temperature after 19 minutes, and that's my time. And the surroundings or the room or the medium is 71. So 260 minus 71 equals 350 minus 71. E to the negative k time is 19 minutes. All right, I'm definitely going to need help here with my subtracting. 189 equals 279. If I could write what I said. Thank you. And I'm going to write that as 19K. All right. What do I do first? 189 over 279. And then do ln of both sides. And this will move out in front. So we end up with the ln of whatever that gobbledygook is going to be. Equals negative 19k ln of e, which is just 1. So we end up having to divide this by negative 19 to get our k value. Show as much work as you can on the quiz so that I can give you partial credit if I need to. Give you a math error instead of a concept error. Okay, tell me what it was. ln of 189 divided by 279. Thank you. And then divided by, okay, so 0.0205. Please try to go out several places. I would prefer like 5 on this. 4 places, I mean. What did I just say? 0205. Okay. Then we go back, and which numbers do we no longer use? The 19 minutes and the 260, because we want the new final temperature, okay? The new final temperature to be 125, and we're looking for T this time, and we're using our K value. All right, so if we set it up, it would say 125 minus 71 equals 350 minus 71 e to the negative 0.0205 t. 54, how did I do? And this is still 279. So we're going to divide. (54 over 279). Still take the log of both sides. And then when this comes out front, we're going to need to divide by that negative 0.0205 to get T. Anybody else getting 80.1? Is that what that says? It's really tiny. Okay, so around 80 minutes. That's a long time to wait for what? Our cake? All right. I think that's a little unrealistic, but since Hofbauer makes these up, they're often unrealistic. Okay, guys, this is the one that's going to kill you. And I've tried to practice this a couple times with you, but I need you to be real careful that you understand this question because it's got several parts and it's not only on this quiz, it's on the final. So is this what it says on the pink sheet? Is that right? Okay. A bacteria is dying. It is being halved every 9 hours. If 50,000 such bacteria are placed in a petri dish, calculate the amount of time to the nearest tenth of an hour needed for the bacteria to be under 6,000. After rounding to the nearest tenth, find the actual number of bacteria that are present under 6,000. Okay, so we want to hit 6,000, starting with what? 50,000. And it is doing what is our rate? 1/2. Now, are we looking for T or is T 9 hours? Are we looking for H or is H 9 hours? I think it says on your, what does it say on your pink sheet? Yes, H is the length of half-life. So H is this 9 hours. So it's T over H. A 9, sorry. T over 9. All right, steps to solve. Anybody? So 6,000 divided by 50,000. A bunch of those zeros will cancel off, but I'm just going to leave it. I have 1/2 T over 9 to the T over 9. Now what? No one's going to do 50,000 times a half, right? Because that's just going to be a big old nasty concept error. We need to take the log of both sides, whatever kind you want. You can use ln again. And now this T over 9 is going to come out in front here. Now what? Yeah, so we're trying to get the T by itself. So I'm going to do log of 6,000 over 50,000. Right now I have T over N, 9, T over 9, times the log of 1/2. So I'm going to divide that log of 1/2 over here. And then I'll still need to multiply by 9, right? Don't forget. You have to type log twice. There's no shortcut. And close your parentheses top and bottom. And then when you get that answer, you want to multiply by 9. Okay. Do you remember what we said about rounding? If we just put 27.5, let's check if that's going to work. Can we put a 27.5 back in? See what happens? So we started with how many bacteria? 50,000 times 1/2 to the power of, what did we just get? 27.5 divided by 9. Did we get under 6,000 bacteria? No. So what do we have to do? It's not right. Yes, we needed to take that 27.5 and round it up to 27.6. So we're going to go back and write down our answer as 27.6. And then our work down here is going to be to change this decimal up here to 27.6 so that we now have less. Okay, so we ended up having to round up to 27.6 hours. Otherwise, we don't get below 6,000. Now, this question says, after we've rounded and realized we're finally under 6,000, how many bacteria under 6,000 are we? So now we have to take 6,000 minus whole number of bacteria, which was 5968. Is that 32, guys? Okay, so what we did here, just so we're clear, is we took 50,000 times 1/2 to the 27.6 divided by 9, and then we took off the 6,000. Well, and it would end up, if we did it in that order, it would end up negative 32, but that's how many we're under. Yes, no? Okay. That's what's on the quiz. Are we good?